Okay, now the meeting is recorded. Welcome to the July 13th SIG Apps meeting. I'm your host today, Janet, and together with me is the Ken and Matt. They'll be our co-host. So let me share my screen. Can you all see my screen? Okay. So we have one announcement from the community. So there's a Meet Our Contributors meeting. That's a monthly 1-hour opportunity. You can go there, ask questions, and then you can also participate in peer reviews. So peer code reviews. So you can ping Paris if you are interested. And then we don't have any demos today, and we have several discussions. The first one is daemon set search tab from Clayton. Clayton, do you want to talk about it?
Sure. So can everybody hear me?
Yes.
Great.
Yep.
So we hit this in general, which was there's a number of system components, kube runs. We hit this kind of from like a distribution mindset of you have a kube cluster and you want to run infrastructure components that other things depend on, webhooks, SDN, CSI drivers, host level services that everybody needs. One of the things that came out of that was that it's actually extremely difficult with a daemon set today to update it and to keep availability on that particular node of whatever the service is. So like some things on a node, yeah, you don't need to be running all the time. You know, you can shut down, have retries. You can definitely minimize that disruption with a daemon set because the daemon set strategy today is delete and recreate. If you're pulling a new image on that node, that image pull, usually could take a couple seconds. Sometimes it could take 20, 30 seconds. But in some environments, in worst case, it might take minutes. There's also like, do you need to do startup code? Does kubelet choke during the upgrade? Is there any kind of disruption to the kubelet or the API server that would prevent the next stage of the update taking up? So there's a couple of approaches. I have those down in alternatives, but one of them was we had always kind of talked about this for daemon sets, which was the idea that we did this for deployments from the very beginning because people, the replica set, you want to go from 1 to 2 and then back down to 1. You don't want to go from 1 to 0 to 1 in many cases by default with a lot of stateless workloads, because the whole point of a stateless workload is you can run multiple copies of it. When we had talked about it for daemon sets, the idea would be, well, if you could run 2 daemon set pods on the same node at the same time, not every workload is going to magically handle that correctly. But if you need to keep availability, really the only way that you're going to be able to hand off is if you can get 2 copies of your code running at the same time. And daemon sets do not allow that today. You can emulate it by doing something on top of daemon sets, like you could have 2 daemon sets and you could manage labels. And since we already kind of had this concept in deployments, and we already kind of had talked about it with something we could do for daemon sets, I felt like the simplest thing was, given the challenges people had raised in a number of issues, I don't know if I captured all of the links, but there's been like 7 discussions that have gone on in the last 2 years about, I'm trying to run system components and daemon sets. I need something, and people had a number of workarounds. This kind of approach tries to kind of find like a happy middle ground, which is not going to be magic for everyone. It's not magic like deployment surge would be. But it would effectively be, instead of doing delete the pod and then start the new one, it would be start the new one, and then when that's up and ready, signal the other one to be deleted. Things can still go wrong. If your first pod crashes, thinking through the implications of that. Usually the answer is if your goal is to have high availability and you can't maintain that in your app, that's your problem. If like you've got some implication in your code and you didn't do it right, well, you aren't going to be able to do it right anyway. There's no magic in Cube that can handle handoffs between two things. You know, even replica sets, if you don't do shutdown correctly with gracefulness and all that, you're going to lose connections. That's just, there's no magic for that. So kind of a compromise solution. I think it's kind of an advanced case, but it's probably pretty useful for people doing infrastructure, CSI drivers, networking plugins, host level services that need to maintain uptime, like anybody doing a service local endpoint that another service is expected to call Unix domain socket. If you have a reason that that process needs to stay running, there needs to be at least one instance of your process running at all times, or you're going to drop stuff or fail in some dimension. This would help you through it. And I had like a basic prototype of this. Actually, the daemon set code in the controller was actually reasonably well set up to support this. What isn't simple is making sure that we have all the exhaustive testing. So I did some of the basic testing and worked through like what problems would I hit if I actually tried to use this, but I do not have the extensive set of, you know, the hundreds of unit tests we need to make sure the controller works in all cases.
So quick question. Does anyone remember offhand the status of service topology? When does that go beta?
Soon. I don't know if I don't think it hit 119 though.
Okay. So, I mean, to me, this makes it like one of the most major, like kind of surveying what daemon sets are out there that would benefit by this, scarce resource conflicts that would kind of make it fail in a expected but consistent way is host port conflicts. But if we go forward with this, and then the advice that we give is to move away from host port where possible to node local service topology in order to say, okay, this is how you communicate locally with processor on the same node, it largely alleviates that conflict. The other
pods are not required to declare their host ports. Usually when you declare your host port, it's you want your magic host port versus the more normal, like I'm listening on the host interfaces. Like if you have a high performance load balancer, like an ingress controller, you could be on the pod network, that'll work sometimes. You're not actually registering a host port anyway. You could run an ingress controller on a daemon set and still get pod networking and still not have that scheduling problem, but have the other problem of you can't have, you know, the two instances running at the same time.
Yeah. So, I mean, I think it's something we should do. I think the only other thing that we should consider if we're doing this is, the other thing we always talked about doing was kind of topology aware updates, which is sort of orthogonal to this, because this solves the case where it's like, I want to be able to ensure availability of a particular pod instance controlled by a daemon set and surge it forward. Whereas the topology aware is when I'm doing a rollout, I want to ensure that like I hit one rack or one zone first, because this particular administrative workload communicates with some device or something that's related to the topology of the deployment where I'm incurring increased risk and I want to confine that risk to a particular domain during rollout. The only thing I would want to make sure is that when we do this, we think about the other case to make sure that we're doing it in a way that we don't block going forward with topology aware updates.
Yeah, and the lot, so certainly like there's 3 levels here. This is very node specific. So like the way that daemon set controller works today is most of the stuff gets in and makes decisions about the state of the node as an invariant. And this tweaks that invariant, but it doesn't fundamentally change it. So it would probably increase complexity when we go do the topology aware, but most of that complexity is about selecting the node. Like the example with this, and this is where I think there might be a nuance, is if your previous pod crashes while you're trying to do a handoff, there's very little that's not just like, go ahead and clean up the old one. Because the assumption would be, if you've got 2 instances and the old one's ready and the new one isn't, and the old one dies, the thing to really do is to move forward and then to pause at the higher level, which is that old thing is either broken or stayed, like, you know, if it starts crash looping or if it goes unready, the moment it goes unready, it's really being removed from consideration. The higher level thing is like in a deployment, you've got a gate rolling out anyway, and that gating has to basically work based on the ready status of the nodes anyway. If you have 2 and neither are ready, it's basically the same thing as 1. And it isn't ready. So I'll add some notes to this about how that could be, topology awareness could play into it. I think structurally this feels mostly orthogonal in a good way. Like we haven't backed ourselves into a corner in the update logic or the controller code or how we've talked about daemon sets that would prevent it. But it definitely, I'll add some notes about that in here.
Yeah, and that's my primary concern. And Janet I'll defer to her about the more in-depth implementation.
Yeah, I remember we had someone propose this before, and I think host port being able to run two daemon set pod on the same node at the same time was what's being debated at that time.
It's interesting, and I called that out here. Jordan had brought that up when he did like a first initial pass of that. I'm not actually sure that, and like I'm somewhat biased, but I've never actually used host ports in Cube ever. I've only ever used host networking or node ports. And so I would say I can go do a review of like kind of common daemon sets deployed. I would probably say, unless everyone is using daemon host ports and I'm like totally wrong, I think the argument would be host ports is definitely a portion, like 10, 15, 20, maybe 30% of a certain class of problem. In general, it's no worse than, it's no different than any of the other optional capabilities, which is not every daemon set or not every deployment, for instance, is going to be able to have more than one replica. It doesn't prevent deployment being useful for one replica. It just means that the tunables are there for it. I think some of those arguments probably apply, which is if you set up an impossible thing in a deployment, it's still impossible, right? If you reference a persistent volume that can only be attached to one node and you set two replicas, that is impossible today. It is not a valid use case. It is something that's possible. Our answer is to detect, warn, and then give you the option to go change it. Now, there is something going into storage that actually changes that now. So storage is getting an alpha feature in 1.19 that allows PVCs to be instantiated on a per pod basis and share the pod's lifecycle. The implication of that, if we had taken a hard rule and said, well, we'll do a bunch of validation on deployments around having replica size greater than 1, but a PVC reference, would actually be incorrect now because of the way that is being handled. So I felt like host port is situational. It doesn't remove the need in general for this pattern. And we could probably say solving the host port scheduling problem with a recommendation above warn or fail gracefully can be done as a follow-up. If we've misinterpreted how many host ports are out there in terms of a total percentage of daemon sets, then yeah, I would be absolutely open to spending more time on that in the first pass.
Okay, sounds good.
And I will add I'll go do some research on number of people using host ports and scenarios that they're doing it. My gut is that host network has mostly subsumed that for like networking plugins. And I do not know what people are doing with CSI drivers, but I haven't seen a ton of host port usage there. Some casual browsing I did.
So also, if I remember correctly, the reason we decided the original proposal that was kind of similar to this was create before delete strategy, not adding max surge. And we didn't decide to not do it ever. We decided that we didn't want to do it then, and we didn't want to block going to V1 on it. There are some subtle differences to what was proposed there to what's proposed here, especially from like how I would wrap my head around the implementation standpoint. Create before delete was actually kind of monitoring the status of pods on a node and trying to explicitly create a new one prior to deleting an old one, whereas max surge seems a little bit more simple in terms of I'm just going to surge up and it's a controllable parameter for my surge rate and then surge back down. Well,
right, yeah.
After the fact.
Yeah, it's the slightly higher meta. I liked it because the API was consistent with deployments, and but it is a subtly different implementation. It could be that create before. I was like, you're just overall like not inventing new concepts when it's close enough And I feel like the surge percentage would tie more closely with topology versus create before delete, which then might still require a percentage for how you behave.
We've also accepted to implement max surge for stateful set as well.
Yeah.
So, I mean, it seems reasonable to round out and have some implementation of the semantic if we think we can do it safely across the entire API surface, to me.
And I think good documentation is the key here. Certainly, I don't know that everybody could get deployment max surge correct without actually reading the description. And I know the amount of time Tomasz and others spent in the early days of review, we got it wrong subtly many times. So there's an element of no matter what, there's going to be some complexity. Getting a clear human understandable description of it is probably the similarities between them. They're already somewhat nuanced processes, like the difference between 1 and 0, percentages rounding down and rounding up. And as I was copying the deployment doc, like the deployment Go doc, to think about what surge would be, those edge cases and the way it was described, it actually helped because it was easy to take the sentence for a deployment and change, like talk about how it applied specifically for daemon set, but kept all of the same, like, oh, I think about them the same. It's just which, like I'm choosing which machine to do the pod on versus choosing which replica set to scale down. So there were some elements of it that had some similarities that I liked. It's going to be complicated either way, I think. And having less API concepts with better doc is probably where I would lean to from a reviewing perspective. So if there's any other feedback, just let me know and I'll take it in the doc. Got some comments from Tomasz and Jordan. Jordan was kind of asking some of these same questions based on his memory. If there's anything anybody missed, I'll add it and try to get this in a reviewable state soon for subsequent discussion.
So Clayton, regarding the host port, would we introduce a validation for the rolling update strategy that would actually disallow it?
I think we could in this case. It's certainly always easier to relax that validation later if we decide it's not too much of an issue. Today, you will not get scheduled if you have a host port unless you've heavily customized. We do not block on replica size greater than 1 for PVCs and replica sets, and I think that's probably okay. I'm not proposing to change that here. I would probably prefer to add the validation to explicitly flag it right now because this is a new field. And then if we need to relax the validation in the future because we actually come up with a different solution.
Yeah, that would be great because this is the only time we can actually choose to introduce that validation, right?
Yeah.
Well, so that's one thing that's still not super clear to me, because if we go, like, yes, if we're saying we're adding this as something that's V1 feature gated with an alpha flag, but it's a feature on a V1 API, the reasonable assumption, I guess, is that like if you add validation that breaks it later, then effectively what you've done is make a backward incompatible change. But the interaction with the alpha field gate, like in theory, I think you could change the validation while the alpha field gate is still on, even though the API is V1. Yeah. And it would not be breaking users because you've chosen to turn up a cluster with alpha fields enabled. And before we go beta, we're not making any promises about not breaking this particular feature, even though the API is V1.
Right, and the surge, to be clear, because it is a new field, will default to not specified. It has to, because we're adding something novel and we already have a default on update strategy, which is the percentage of daemon sets to go roll on. So the default surge, and it's called out here, is 0. You have to explicitly opt into it. Because you have to explicitly opt into it, the act of turning that on while the flag is on, the validation only applies when you have that set and the flag is on and you are changing the values. And this is like This is like Jordan has drilled into me like the reviewer list for when you add a feature gate with validation and add fields, because I forget it every time. But the if that value was already set and you somehow got into that state, we would not validate on it. We only validate the changed value in cases like this. So if you had somehow stood up an alpha cluster, we would go through it. I'll add some of that to the KEP as well for upgrade scenarios.
Yeah, the storage migration was a particular concern of mine, right?
Yep.
Because then you do a specific update on it, right?
Yeah. If generally the rules we have settled on is if you have invalid data in storage and you did not change that in your update, we do not validate it. That is the kind of the default premise, because unfortunately, for whatever reason, you got into that state and we have to honor it, especially going from alpha to beta transition. But you are still broken. We will tell you you're broken when you change it, and you'll have to delete and recreate that object or clear the field. And you should be able to clear the field once the field gate is on anyway. So it's a solvable problem, I think, for this. Say we changed the validation, you got it into the state. If you tried to update anything on that changed it, we would gate your update again.
Right.
So I'm not hearing any objections to merging this KEP as, what's the first status? Accepted?
I think so. I don't know.
Yeah.
I don't know what it is this year.
As that thing, what that thing is, and moving forward with the implementation and getting it to an implementable state. So unless anybody is explicitly saying we should not do this, and I don't see any feedback on the KEP itself where anyone in the community is saying we should not do this, I guess we can move forward, or does anyone have objections?
I mean, I think I like it. I mean, I think we have been waiting for similar functionality for daemon sets for sure. I'll take a look at it and review it once more, but I haven't reviewed it at all. So I'll review it, and I'll be looking forward to validations with respect to host support and things like that.
Just a real quick, I think it's not accepted. It's marked as either provisional or implementable, depending on where we think it's at.
Okay. I will put it in whatever the first state is.
That would be provisional. And when we accept it and it's in a provisional state, then it becomes implementable when somebody can build off of it. And then once something's been built, then it's implemented.
Okay. Thanks, Matt.
Yeah. I had to go look at the docs. I didn't know.
Cool. Thanks, everybody.
Okay, moving on to the next one. We have this deployment blue-green strategy. Do we have Carl here to talk about this one?
We do now. Can you hear me?
Yeah.
Cool. Sure. So I made a proposal based on adding a blue-green strategy to the deployment strategy field, basically adding a new value or option in the map. There's also a little bit in here about potentially adding a canary later, but it's not necessarily a requirement. And so let's see, I think the idea is basically to make the old replica set stay around while the new one is rolling out. Instead of doing a sort of gradual one-by-one replacement of pods in scaling down the old replica set while the new replica set scales up, we would just make a new replica set at the maximum or the current scale of the old replica set. and then the new replica set would be labeled differently than the old replica set. They would have sort of a managed label. I didn't necessarily specify what that would be, but one option to be just have a color, and the old one would be blue and the new one would be green. That way you could specify, say, a service that only goes to blues and another service that only goes to greens. And that way the user can sort of decide when the client rolls over to the new replica set. And so what this would mean, and sort of different than what we have now, is that instead of sort of automatically deleting the old replica set when the new replica set is scaled up, we would have to have some sort of policy on how to decide when to retire the old replica set, or say delete the new one and roll back to the old one. So there's the current mechanism for rollback is using the rollout undo, or sort of the rolling back to a specific revision of the deployment, I believe, which is a whole different resource management. There's a sort of a generic resource for managing the undos, but it only currently implements for the deployment, I believe, which means there's some flexibility in changing that. What I didn't do is necessarily specify how that should change. I think that is sort of up for discussion because I don't know the ins and outs of the sort of rollout functionality. So I put together this proposal and then had some back and forth conversations, and then I put together a doc that sort of talks through use cases. So it might be better or more clear if we go through the doc. Let me pull it up and see if I put it in that enhancement. It looks like I didn't post it in there, so I'll do that, and then you can just open it up. All right, go back to the feature request, and then scroll to the bottom, and I put it in one of the comments. Refresh the page. So I basically used the kept format for this, but since there's not a great way to comment on the sort of pre-approval status, I put it in a doc. Feel free to leave comments or suggestions in the doc before I transfer it to a GitHub page, provided you guys want to move forward with this. I guess just walking through the goals here for a second. The whole reason I put this in here isn't sort of to obsolete other solutions that already do blue-green, but rather to upstream common functionality that's been implemented in a number of different projects. I'd like to have a sort of reverse incompatible way to add this, which I think is pretty standard in the Kubernetes API and pretty much required in order to make any sort of change to it. I'd like to have sort of a manual continuation policy option where we say like the old replica set is retired after someone makes a change that the new replica set should be kept, or vice versa, that some manual change is made and then the old one is kept and the new one is deleted. I'd like to default to a sort of automatic continuation policy, which would be usable sort of out of the box, so that when the new replica set comes up, if all the pods are ready, then the old one gets automatically deleted. That one is useful if there's reversing compatibility, but it doesn't provide any sort of extra validation in terms of having a sort of a way to tell that the thing is healthy other than the pods individually being healthy. So if you, let's see, I already talked about rolling forward and rolling back. And then what I've seen when using blue-green rollouts myself is that oftentimes you're not doing a blue-green rollout all the time. You might do a blue-green rollout for sort of a database schema migration, for example. So you might want to switch back and forth between rolling and blue-green rollouts. And then sort of non-goals is I'm not really planning on automating the continuation policy decision any more advanced than saying all the pods are ready, because we already have the ability to do that. But if someone wants to add custom automation on top, say like Spinnaker or Knative, sort of deciding that they want to do a continuation automatically, then they can make a change with a controller relatively easily. And then I wasn't planning on adding to stateful set, but that could be changed later if we deem this sort of experiment successful in the deployment API. Because I can go through one of the use cases, or I can just leave this for comments. You go through a user story if you care about the spec, or you guys can just read and follow up on this. I guess outstanding questions is sort of how do we use the rollout pause resume to make this work? Can we add a continue command, or will that be confusing? What should happen if a change is made to the deployment while two replica sets revisions are active? Can we use sort of the pause functionality to make that happen? Then no changes are allowed. Or rather, if changes are made, the controller won't do anything until it's unpaused. That's one option for rolling out. And then are changes needed for kube control, rollout, undo to delete the new replica set without replacing the old replica set, or will that work out of the box? That's sort of an implementation detail that I'm not really sure how that works yet. These questions were right above the user story, but basically you guys can all page through that doc yourself if you want. I don't necessarily expect you guys to approve and agree right now, but I wanted to have some sort of synchronous discussion with what do you guys think about it?
Okay, I'll take a look at this proposal. Can you have some feedback on this?
My main question, well, I have two questions, but my main one is, did you reach out to, so, I mean, two of the main kind of controllers that orchestrate this kind of workflow specifically, three actually, Spinnaker, you have Argo rollouts, and then you have Weave Flux Flagger. Argo and Flux have merged with the sponsorship of AWS to become Argo Flux. Are any of these communities like asking for this in core? Because like if they're all coming together and saying this is something that would like streamline the implementation that all of us will consume, that would be kind of more of a strong motivator than building it first and hoping they'll consume it later. Because it's not clear to me that they necessarily would, looking at the implementation of what they have. Like if I go and build this, I don't see how it directly plugs into the workflow orchestration that they've already implemented. I don't know how to build it such that I can guarantee that it is consumable or even necessarily attractive to them. So if they have like requirements that they'd like to pass into core, that we can come up with something where it's like, okay, now we know we've met a minimum set of requirements and we have some level of commitment from our partners in the open source community to actually consume it if we build it. That would be a stronger motivator to me than trying to build it first.
So I have not reached out yet to them outside of like one guy who responded to my Twitter queries. I'm not entirely sure how to do that because I don't know what their change processes are. I have used sort of Knative just for experimentation, and I've used Spinnaker in production, but I haven't used Argo yet. So I don't have sort of firsthand knowledge about how those would map in order to write that myself out. So there needs to be some sort of engagement with them to get them to give feedback. And I figured the easiest way to start that off was to have a proposal that they could comment on.
Okay, so that sounds reasonable. So like putting this out to a broader community might be a good idea to get feedback, because all of those technologies actually have more than a subtly different underlying implementation. So I'm not sure if this actually meets the requirements, but like getting some sense of what their requirements are and what would fit would be, to me, like the first thing to do to try to move it forward. So we know that we are at least building the right thing if we choose to build it. Then my other question would be, so typically the way I do red-black or the way I do Canary is actually just using 2 deployments and then switching the service over. Like I can have deployment 1, deployment 2, which is red deployment, green, or black deployment, blue deployment, green deployment, scale 1 up, scale 1 down, and switch the service to select different labels in order to route traffic as appropriate for the red-black. Canary is a bit more complicated, and really without Istio, because of the way, like if you're using Kubi proxy in IP tables mode, it's just kind of, unless you have very, very large deployments, it's kind of very difficult to control the fraction of traffic that you're actually sending to the Canary in order to do any type of even manual Canary analysis. So like, instead of using the primitives we already have, like, why does this make it easier? That was the thing that was unclear to me as somebody who kind of uses like both of those strategies with the existing infra.
So one of those, sort of the first question is why is this valuable on the face of it instead of using 2 deployments? And sort of the problem with having 2 deployments is that there's no sort of controller or management scheme that owns both of that deployments. You end up having to write an entirely different system for managing those or doing them manually. And so this provides a way to do it in a more automated fashion where there's an extra deployment and only sort of 1 flag that you would have to flip in order to say, yes, I want to keep the new ones. Which would make it relatively trivial to sort of have a sort of mini controller that says, okay, all these new ones are healthy, and then I flip to the new ones manually or automatically, either one. If you wanted to write your own controller to sort of manage deployments, you could also do that. But as far as I know, nobody has done that in a simple fashion. Like Spinnaker doesn't even do that. Spinnaker manages replica sets by itself inside of the same deployment. So this strategy here is actually doing something very similar to what Spinnaker does, except without needing Spinnaker to do it. Basically it would only have to wait until it was done rather than managing all the individual things. So it would reduce the amount of code that they have there. For Knative, my understanding is that they're doing sort of percentage rollouts and they're managing them via load balancer. And so this solution doesn't necessarily explicitly support percentages, but you could wrap percentages around it. The blue-green implementation wouldn't support granular percentages. It would just be 100% or 0%. If you wanted to support something like what Knative was doing, you'd have to add another deployment strategy that was sort of a canary strategy that allowed specifying either percentages or counts So you could easily sort of integrate part of what Knative is doing with a separate rollout strategy. Have a canary rollout strategy with percentages in it, and then roll those percentages manually or some controller that rolls them. And then you wouldn't necessarily even need the complexity of having the load balancer doing the percentage for you, because you have backends percentages being different. It might be that you can't match that percentage exactly because you don't have that particular number of instances, replicas, but you could make a sort of a best fit attempt. That, like, using that for a sort of canary strategy is a sort of a different approach. It's a replica set based instead of load balancer based, and so I'm not sure that Knative would actually go for that, but they might. I would have to talk to them. I think it would be different enough that there might be sort of two ways to do it. But the nice thing about this strategy is that it's sort of simpler than using a load balancer and doesn't require sort of changes to load balancing setup. You could easily have two ingresses that point to two services and just switch between them by like DNS on the front end, or having one load balancer that is Kubernetes aware that can decide which service to route its backends to. In terms of Argo, I'm not fully aware about how their system works. I think your second question was, now I don't remember.
So for Canary deployments, which was also, I'm looking at it seems like maybe it's not worth talking about, because it seems like in this document you've not really gone too deep with the Canary rollout, and you've left it as optional. But I haven't seen anyone make this work without using something like Istio or Linkerd in order to route a fractional percentage of traffic to the Canary, just because most people run Kubi proxy in IP tables mode, which does random connection assignment and doesn't guarantee you any type of particular traffic mixture for anything going through a service, right? So without using something like Istio or Linkerd, which does interception at the application layer and routing individual requests to actually get a good kind of mix of traffic to the Canary, I don't know how that would work or how we would take it into core.
I don't think that's necessarily true. There was sort of two statements in there I would debate. I mean, the first one is that everybody uses kube proxy to get to their service, but that's at the sort of IP layer. If you have
most clusters use Kubi, very many clusters use Kubi proxy in IP tables mode.
I'm not saying it's not used. You just said most people use it. I think a lot of people use like an Nginx or Ingress style directly to the pods based on the service resolution, which doesn't necessarily use IP table or doesn't specifically depend on that functionality. But with this particular design, both replica sets are going to be matched by the deployment's name in sort of a kubedns way. But if you have a service route to it, you can sort of decide how you're doing it. You either have one service that matches the labels selectors that you supplied, or you have like two services, one that's blue and one that's green, and then those are mapping directly to the replica set of your choice, not both replica sets. So the kube proxy IP table management would go directly to, would be of your choice depending on how you set up the service. You could either have it go manage to all of them or to one or the other. And I think one or the other is more valuable for blue-green, but if you're doing Canary, you might want it to route to both. And sort of a Canary scenario, which I didn't go fully through here, but sort of suggested as a possible extension, was like if you're going to do the Canary, you would like specify what percent you wanted of the old and what percent you wanted of the new, and then the service that routes to both of those would, randomly route to them based on the backend percentages. So you wouldn't have sort of a load balancer suite of percentages. You'd have like a randomization on the back end of which backend you receive.
Yeah, but So I wouldn't understand how that would work in either IP tables proxy mode or in IPVS mode for a Kubi proxy, right? Like I can change IPVS to actually do those types of more customizable load balancing of connections going out. But in IP table proxy mode, if I have a single service that's fronting each, random connection assignment is all I get for the most part.
You get random connection assignment to one of those two replica sets that are at different percentages. So if the first one has 100% and the second one has 1%, 1% of the, or 1% or less of those connections would go to that second one.
And that works well. So in the event that I have very large deployments, that actually works well and is consistent with what we suggest for 2 deployment canaries, right? Which is what we have on the website. But for one of the reasons that Argo rollouts and Flagger became popular is that it doesn't particularly work well for smaller deployments, because when you're doing, if the number of connections that are being requested are much greater than the number of pods, you still don't necessarily get a consistent amount of traffic across them. And then connection utilization from upstream clients doesn't actually necessarily give you 10% of traffic. It's very hard to achieve, like, just by manipulating the capacity that's serving on the back ends, any type of reasonable distribution of traffic.
All right. I mean, that's a reasonable argument. One way you can get around that is by still using the sort of blue-green color labels that you would get, but using that in a canary scenario where you have sort of less percentage rolled out for the one side, and then you use your ingress strategy to decide which service you route traffic to, whether it's the canary or the rollback. There is sort of a downside with that strategy, is that the auto scaling might not kick in the same way if you're halfway through a canary rollout. But I think most of the time people disable auto scaling while doing a blue-green rollout. That's been my experience. Auto scaling during a rolling is a little confusing, but anyway, I didn't dig into the canary. If you think it's a requirement that, like, it's not worth investing into the blue-green without also having the canary, then I can spell that out. But
actually, no, but I might make it separate just to focus on one than the other. Up to you, your proposal.
How should I follow up with those communities? Is there good ingress points?
I can offline. I can direct you to some people for native, Knative. I have some familiarity with them. I know some people in Flux. I would actually say that, like, Flux tends to be fairly responsive. Argo, I've had less personally interaction with, so I don't know how responsive they are. And the Spinnaker guys, people tend to be also very responsive. So, I mean, if you, like, open this up and then just, link them out and say, hey, I'm interested in doing this, you can see if you can get, kind of those people to get together and say, hey, we're also interested in this, or at least get a signal. I mean, like, if you open it up as an issue and none of them respond or have any interest in contributing to it or consuming it, then that says something too, right?
Okay. Do you think this is only valuable if we can get them on board? Because, like, this would be totally reverse compatible. They would still have their functionality working the way it is. We'll just add another way to do it that they could, migrate to or not.
I mean, I think the way I look at it is this, right? Like, so for GetOps-based workflows and for custom orchestration of deployments, there are a lot of solutions that are out there in the open source already. And people seem to be using them. They seem to be happy with them. From the SIG architecture standpoint, the position's kind of been taken that we don't think of built-in types as special, and that custom resource definitions are kind of the future. And we expect people to build orchestration on top of Kubernetes, either leveraging the workloads APIs or not, in order to implement custom workflows. And the kind of direction we'd like to go is that no resource is special. There's no custom resource. there's just a resource and you can bring your own. There's a set of default ones that most clusters will have. There's a set of resources that you have to have in general to be compliant with the Kubernetes API specification, but we don't want to treat them as special. So if we already have a set that are out there for our end users, and our end users aren't really pushing on us to saying that the technologies that are available in the open source are insufficient to meet my use case, we really need you guys to do something separate, then the only value that we can bring as a SIG is to kind of converge, like provide utility to the people who are providing those open source, the other open source resources, and try to get continuity, to get kind of a convergence of the implementation so that you have one standard implementation that just works, which seemed to be one of the goals of your proposal. And I think that's like, that is what kind of seemed attractive to me. Like if we can get the open source community to converge on a standard implementation that's robust, that's probably better for the end user than having very many implementations that are just slightly disparate.
Yep.
So if we can do that, that to me seems to be a win. But I don't see an impetus from like the end user community saying that, hey, we really need you to do blue green because what's been implemented by other open source projects is insufficient for our use cases.
Sure. So I get where you're coming from. I would say that my primary motivation of writing this is that a lot of those higher level solutions, when trying to use them, are both a lot of extra work to add on top of Kubernetes, and a lot of them are doing something like replacing the deployment with another custom resource. So they have to re-implement 90% of deployment in order to get the extra functionality, because they can't use the deployment and still do canary rollouts or blue-green rollouts, or they've decided that they don't want to, and so they've made a new custom resource. So part of the impetus is to sort of reduce the complexity and disparate functionality between those implementations. But part of it is also that, you know, there's an API with a rollout strategy here, and it doesn't have the rollout strategies that people want to use. It only has rolling, and you would think it should also have canary and blue-green, because that's how people think about these things as like parallel to each other. But those functionalities aren't here in deployment. They have to go look elsewhere for them. So there's sort of an API confusion where you know, you would expect it to be here and it's not.
I think the point that Ken was trying to make is that core isn't for experimenting, right? So we usually propose people to implement it as CRD, to actually, well, test it, make sure the API is what is intended for. That's what the community agrees on, and then we would consider like adopting it. But
so you want me to completely replace the deployment controller and make a fork of it so that I can test it?
Well, not you in isolation, right? But like, think of it like this: deployment itself comes from deployment config, which is implemented inside of OpenShift, and it became so obviously valuable that it was adopted into core just because like everyone wanted it, right? So supposing we could get like, let's say some fraction of the community that's interested in doing orchestration on top of K that's for value add, whether it's Argo rollout or the Argo Flux project or Spinnaker or whatever, interested in it. One thing we could do is like fork deployment as an open source SIG sponsored project, like inside of SIG Apps, and provide a CRD there that would be commonly used across the community. And if we like it, then promote it as a built-in type if we feel that's necessary. Or if we don't feel it's necessary, there are types that are maintained out of tree by a SIG, right? So it doesn't necessarily have to be a built-in type in order to be supported or maintained by the Kubernetes community. There are a lot of different paths there that achieve the same result of converging the community around an individual resource that's robust and well implemented and meets the needs of people who want to implement blue, green, and canary on top of Kubernetes. But no, we're not saying you should go do it in isolation unless that's something that you think you want to do.
So this is Mayank. I think my team has been closely working with Argo rollout, so I can definitely share this proposal with them. I briefly looked at the Argo rollout code, and I basically echo what Carl is saying in terms of how Argo rollout works. It essentially replicates, it essentially creates two replica sets and and manages most of what deployment controller already does. But I'm still like not confident that whether I should move all my deployments to Argo rollouts, because I know I need max surge and max unavailable and all that. And I don't know if Argo rollout, in addition to implementing blue-green, implements those correctly and figures out all the corner cases that Kubernetes over its maturing process has already figured out and fixed the issues there, right? So I think I echo some of what Carl is saying, but I completely agree that I mean, if we build something that nobody wants, right? I mean, if we go and ask Argo rollout and Flagger and what else, right? They all are craving for this functionality, saying that yes, if this was available, I can basically remove a lot of these bugs from my thing, and I don't have to keep on syncing. If there are issues that are fixed in deployment controller, I might have to fix it here. So yeah, I think it's a good idea to just share it with these all blue-green implementing controllers and get their feedback on whether this is a great idea and whether they would be open to re-implementing their controllers using the core blue-green functionality that we would implement, right? But yeah, I'll share this proposal in the Argo rollout Slack and see what they have to say.
All right, thanks. Yeah, I think Knative is in a similar space where they have reduced the functionality to a core, and they've also added a custom resource on top. And so that custom resource doesn't do everything that a deployment does, sort of does a subset of it. So if you want some of the features that deployment has that Knative doesn't have, you can't get Knative's, blue, green, or canary without, sacrificing the extra features that deployment has. And Spinnaker doesn't quite have that, but sort of does, because it does some manual management of the replica sets while the deployment still exists. I haven't looked at the code to see how that works, but anyway, I suspect that most of these guys would be happier to go along with it if there was both a blue-green and a canary solution, because some of them have both, or most of them have both, and if they have already invested in both, it might be hard to detangle them to take advantage of a new functionality in the base deployments.
Janet.
But it sounds like we need to write a separate implementation to have them play with and get them on board first.
I don't know if you need to, but I think I would start with going out and reaching out to them and seeing what their requirements are and if they would use it. And then let's have a discussion. Maybe we could start a working group within the SIG to have a discussion about what we can do here in order to try to converge solutions in the community and provide something that's robust and featureful. But Janet, you've said some stuff, you've been a little bit quiet, and you're kind of one of the, deployment experts. Do you have anything to add?
So this has been brought up several times before as well. And previously we were not convinced that this is a feature that we need to implement in the core. So I'll need to go take a look at this details of this proposal and to see what's different in this proposal.
Do you remember why they were not included?
It's mostly the same reason that Ken just mentioned. But we prefer this to be out of core.
All right, well, if it's out of core, then we're gonna have to keep on making custom resources to replace deployment and not using deployment, which is what people are already doing.
Well, but I mean, again, there's a space there. There's do it as a built-in type, right? There's everyone writes their own custom resource that's completely divergent. And then we come together as a SIG and as an open source community, including multiple projects, and build one custom resource that everybody consumes, right? So, I mean, there's multiple solutions in that space. Right now we're at one where everybody's just kind of doing their own thing, and maybe there's some problems there. We don't necessarily have to go all the way to 3 where we modify the existing deployment. We may find that 2 has the most value. Or maybe it is 3. I think having discovery and having conversations with the other open source projects to try to figure out like what their needs are and what the best solution to meet their needs is would be my first step. That way we have some evidence to actually support a direction.
Okay, we're now 5 minutes over, so I'm going to end this meeting. Thanks everyone for coming. See you next time.
Thanks.
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 Thanks. Bye.